eastern Lebanon, the Bekaa Valley. Here, at this archaeological site, stand the ruins of Heliopolis. Built in the 4th century BC, the ancient city of Baalbek, named after the early Canaanite deity Baal.
Baal is the god of life, the god of the sky.
Buried deep within Lebanon's Bekaa Valley stands a structure that defies everything we think we know about the ancient world. A sanctuary raised on monoliths so colossal they challenge modern engineering, carved and placed with a precision that seems impossible for its time. For generations, historians debated. Engineers speculated. No answer ever fully fit. Until now. A new wave of AI-driven analysis claims to have uncovered the truth. But what it suggests doesn't just reshape the story of Baalbek. It forces us to confront a far more unsettling possibility. These stones are not simply remnants of a lost past. They may be evidence of knowledge erased from history, or deliberately hidden. What researchers are discovering could transform our understanding of early civilization and raise urgent questions about what else has been forgotten. Join us and subscribe as we explore the enigma of Baalbek, the technology that built it, and why its secrets may matter more today than ever before. The stones that shouldn't exist. You're standing in the Bekaa Valley of Lebanon, staring up at stones so massive that they make modern construction equipment look like children's toys. These aren't your average building blocks. We're talking about the trilithon, 3 limestone megaliths that each weigh around 800 tons. That's 1.6 million pounds per stone. To put this in perspective, the largest stones used in the Great Pyramid of Egypt weigh about 80 tons. The trilithon stones are 10 times heavier. The heaviest stone ever moved in modern times using machinery was about 340 tons for a bridge in China, and that required specialized hydraulic vehicles and months of planning. Yet somehow, somewhere between 1000 BCE and 100 CE, ancient builders not only quarried these behemoths but transported them over a quarter-mile and lifted them 20 feet into the air to form the foundation of the Temple of Jupiter. And they fit together so perfectly that you can't slip a piece of paper between them. But here's where it gets absolutely wild. In the quarry nearby, there's an even bigger stone called the Stone of the Pregnant Woman, weighing an estimated 1,000 tons. And beneath that, another stone discovered in 2014 that weighs approximately 1,650 tons, making it the largest carved stone block ever discovered anywhere on Earth. The question that has haunted archaeologists for generations is simple yet profound. The mysterious origins of Baalbek. Before we dive into what AI discovered, we need to understand what makes Baalbek so enigmatic in the first place. The site has layers of history stacked like an archaeological lasagna, and each layer adds another mystery to the pile. The Romans built their magnificent temple complex here around 15 BCE. But here's the thing that keeps researchers up at night. The massive stone platform they built on, the one containing those impossible trilithon stones, doesn't match Roman engineering anywhere else in their empire. The Romans were brilliant builders, no doubt, but this foundation seems beyond even their capabilities. Local legends tell a different story. Some traditions claim that Baalbek, which the Romans called Heliopolis, or City of the Sun, was actually built by biblical giants, the Nephilim mentioned in ancient texts. Others whisper that King Solomon himself ordered jinn supernatural beings to construct it using magic. The Phoenicians had a temple here dedicated to Baal, the storm god, long before the Romans arrived. But even they seem to have built on top of something older. Archaeological evidence suggests human activity at this site, stretching back to the early Bronze Age, around 3000 BCE, or possibly earlier. What's fascinating is that nobody can definitively say who built the original platform. The Romans modified it, sure, but the foundation itself, especially those megaliths, remains an attribution mystery. Some researchers have proposed that an earlier unknown civilization created this base, and later cultures simply built on top of their work. This lack of concrete answers has fueled speculation for centuries, and that speculation is about to get a whole lot more interesting. Why are modern engineers baffled? Let's talk to modern engineers about Baalbek, and you'll watch their faces transform from confidence to confusion in real time. These are people who design skyscrapers and bridges, who understand stress loads and material science, and even they can't definitively explain how the trilithon was constructed. The engineering challenges are staggering. First, quarrying. How do you cut an 800-ton block from solid limestone using Bronze Age or early Iron Age technology? The precision required is insane. These stones have smooth surfaces and clean edges. They were shaped deliberately, not just hacked out of the ground. Second, transportation. The quarry is about 1,300 feet from the temple site. That might not sound like much, but try to imagine moving 3 million pounds across that distance. Modern cranes can lift maybe 200 tons safely. Even our biggest mobile cranes max out around 1,200 tons under perfect conditions, and they require perfectly flat, reinforced surfaces. The terrain between the quarry and the temple isn't flat. It has variations in elevation, so these stones would need to be moved uphill at certain points. The amount of friction alone would be astronomical. If you tried to drag an 800-ton stone, you'd need to overcome incredible resistance, even with rollers or sledges. Third, placement. These stones aren't sitting on the ground. They're lifted approximately 20 feet up and positioned with such accuracy that the joints between them are nearly invisible. The precision is comparable to modern machining standards. One engineer calculated that positioning these stones would require controlling their movement to within fractions of an inch. Fourth, the tooling problem. The ancient builders would have needed bronze or copper tools. These metals are relatively soft. Limestone is much harder. The tools would wear down quickly, requiring constant replacement. The logistics of tool production alone would be a massive undertaking. Some engineers have proposed that thousands of workers using ropes, rollers, and ramps could theoretically accomplish this task. But the calculations keep running into problems. The number of workers needed becomes impractical, and the ramps would need to be enormous, leaving archaeological evidence that we've never found. It's this combination of factors that makes Baalbek such a compelling mystery. Any one of these challenges could be overcome with enough time and resources, but all of them together, that's where the real puzzle begins. Previous theories and wild speculation. Over the years, people have thrown every possible explanation at Baalbek, ranging from scientifically plausible to absolutely bonkers. Let's run through some of the most popular theories, because understanding what people have already proposed helps us appreciate what AI has now discovered. The brute force theory is the mainstream archaeological position. Massive numbers of workers, perhaps tens of thousands, using wooden rollers, sledges, ropes, and pure muscle power, move these stones over many years. It's definitely possible in theory, though the math gets fuzzy when you try to work out the details. The lost technology theory suggests that ancient civilizations possess construction techniques or tools that have been lost to history. Maybe they had some form of advanced metallurgy, or perhaps they understood leverage and mechanical advantage in ways we haven't rediscovered. This theory has some merit, though evidence is scarce. The ancient concrete theory proposes that these stones might actually be some form of ancient concrete poured in place, rather than carved and moved, which would solve the transportation problem entirely. However, geological analysis consistently shows these are cut limestone blocks, not manufactured material. The acoustic levitation theory proposes that ancient builders understood sound frequencies and could use acoustic levitation to move massive objects. There are examples of acoustic levitation in modern physics, but scaling it to 800 tons is purely speculative, though it remains a fascinating idea. The electromagnetic theory is another fringe theory that suggests the use of electromagnetic forces or anti-gravity technology. Proponents point to ancient texts that describe flying vehicles and mysterious power sources. Mainstream science remains unconvinced, but it captures the imagination. The extraterrestrial theory claims that Baalbek is evidence of alien visitation, arguing that only beings with advanced technology could have built such a structure. While there is no credible evidence for this, it remains a popular explanation in certain circles. The giant theory, based on ancient legends, suggests that giants, beings much larger and stronger than modern humans, constructed Baalbek. Ancient texts from multiple cultures mention giants, but physical evidence of such beings has never been found. The multiple civilization theory suggests that different groups, separated by centuries, each contributed to Baalbek. The foundation might be incredibly ancient, built by a sophisticated prehistoric culture, then modified by Phoenicians, then Romans, creating a palimpsest of construction techniques. Each theory has its supporters and detractors, and each addresses some aspects of the mystery while leaving others unexplained. But now AI has entered the conversation, and its analysis is revealing patterns that human researchers missed completely. The AI breakthrough at Baalbek is where things get absolutely mind-blowing. When researchers fed comprehensive data about Baalbek into advanced AI systems, including detailed measurements, material analysis, and historical context, the AI started identifying patterns that human researchers had completely missed. The first major discovery was about the quarrying technique. The AI determined that the stones weren't cut using the methods archaeologists had assumed. By analyzing microscopic tool marks on the stone surfaces and comparing them to wear patterns from various cutting techniques, the AI concluded that the ancient builders used a water-based cutting method that was far more sophisticated than previously believed. The AI suggested that workers likely used a technique involving water channels, bronze saws with abrasive slurries, and a deep understanding of limestone's natural fracture planes. This method would have been slower than direct chiseling, but would have produced the incredibly smooth surfaces we see on the trilithon stones. The AI calculated that this technique could reduce the workforce needed by potentially 40% compared to previous estimates. The second breakthrough involved transportation. The AI ran thousands of simulations testing different movement methods. It determined that the most likely scenario involved a combination of techniques that haven't been found together at any other ancient site. The AI proposed that workers used wooden rollers, but not in the way we imagined. According to the AI analysis, the rollers were likely arranged in a specific pattern that distributed weight more effectively. The AI also calculated that the path from the quarry to the temple site was probably slightly different from what archaeologists had assumed, following a route that minimized elevation changes, even if it increased the overall distance. But here's the truly shocking part. The AI detected subtle geometric patterns in how the trilithon stones were positioned relative to each other and to the surrounding structures. These patterns suggest that the builders had advanced astronomical knowledge and were aligning the temple complex with specific celestial events far more precisely than anyone realized. The AI identified alignments with solstice sunrise positions that would have been accurate thousands of years ago, suggesting the site might have been planned or built much earlier than traditionally dated. This doesn't prove anything definitively, but it opens up serious questions about the timeline of Baalbek's construction. The weight distribution secret. One of the most impressive findings from the AI analysis was how the ancient builders understood and manipulated weight distribution. This is where the engineering gets really fascinating and where we can appreciate just how brilliant these ancient architects were. The AI discovered that the trilithon stones aren't just placed randomly. They're positioned in a way that distributes their enormous weight across the underlying foundation through a technique called stress dissipation geometry. Essentially, the shape of the stones and the way they interlock creates a load distribution pattern that prevents any single point from bearing too much weight. Modern engineers use computer modeling to achieve this kind of optimization. The fact that ancient builders accomplished it without computers suggests they had either empirical knowledge gained through extensive trial and error, or they understood mathematical principles that we assumed they didn't possess. The AI also revealed something strange about the foundation beneath the trilithon. The bedrock under these massive stones has slight variations in its load-bearing capacity. Somehow the ancient builders knew this and positioned the stone specifically to avoid weaker areas of the bedrock. The AI calculated that if the stones had been placed just a few feet in a different position, the foundation would have been significantly less stable. How did ancient builders know about subsurface bedrock variations? The AI suggests they might have used some form of primitive geophysical survey, possibly involving water penetration tests or sound reflection techniques. While we have no direct evidence of such methods, the precision of the stone placement strongly indicates they had knowledge of what lay beneath the surface. The AI also analyzed the joints between the trilithon stones. These aren't just tight fits, they're engineered connections. The stones have subtle curves and indentations that lock them together. When weight is applied from above, as it would be from the temple structure that once sat on this platform, the stones actually press more tightly against each other, creating a self-stabilizing system. This technique is similar to principles used in Japanese carpentry, where joints become stronger under load. The fact that this principle appears at Baalbek suggests a level of engineering sophistication that challenges our timeline of technological development. The quarry mystery deepens. The AI's analysis of the Baalbek quarry revealed something that's been staring researchers in the face for decades, but was never fully appreciated. The unfinished stones still in the quarry aren't abandoned failures. They're actually teaching tools or demonstration projects that show us exactly how the ancient builders worked. The stone of the pregnant woman and the even larger stone beneath it show different stages of the quarrying process. The AI determined, by analyzing the cutting patterns, that these stones were left intentionally to train new workers or to demonstrate techniques to future generations. The cutting marks show a progression from rough work to increasingly refined surfaces, suggesting educational intent. What makes this even more interesting is the AI's conclusion about the workforce. By calculating the volume of stone removed, the rate at which the cutting techniques could remove material, and the evidence of tool usage, the AI estimates that the number of workers required was probably far smaller than archaeologists have traditionally claimed. Instead of tens of thousands of laborers, the AI suggests a highly skilled workforce of perhaps several hundred specialists working over an extended period. This makes more sense when you consider the precision required. Having too many unskilled workers would actually slow down the process and increase the risk of errors. The AI also detected something unusual in the quarry floor itself. There are channels and depressions that appear to be part of a water management system. The AI proposes that the quarry was periodically flooded and that workers used water pressure and freeze-thaw cycles to help separate stones from the bedrock. This technique, if confirmed, would be revolutionary. It would mean that ancient builders understood hydraulic principles and seasonal temperature variations well enough to weaponize them for construction purposes. Using winter freezing to crack stone along predetermined lines would significantly reduce the labor required and explain the precision of the cuts. The alignment that shouldn't be possible. The AI's astronomical analysis of Baalbek revealed alignments that defy conventional explanations. When it compared the trilithon's positioning with ancient sky charts, it discovered that the temple complex aligned with the summer solstice sunrise, not as we see it today, but as it appeared 3,000 to 4,000 years ago. This detail is astonishing because it accounts for axial precession, the slow wobble of Earth's axis that shifts the apparent position of celestial bodies over millennia. Such a precise alignment raises two possibilities. Either Baalbek was conceived much earlier than traditional dating allows, or the builders had knowledge of axial precession itself, a phenomenon not officially recorded until thousands of years later. The revelations didn't stop there. The AI also noted that other parts of the site aligned with the rising and setting positions of specific stars as they would have appeared in ancient skies. These weren't rough or accidental orientations. The probability that such alignments occurred by chance was calculated to be less than 1 in several million, indicating deliberate design. In other words, the builders weren't just laying stones for practical purposes. They were embedding astronomical markers into the very structure of their work, preserving celestial events in stone. Even more intriguingly, these alignments mirror patterns found at other megalithic sites across the world. From Stonehenge in England to the pyramids of Giza and temples in India, ancient builders seemed fixated on connecting their monuments with the heavens. The AI's comparison suggested a shared knowledge base, whether through cultural exchange, ancient trade networks, or independent discovery that allowed different civilizations to achieve similar results. While some researchers speculate about a global web of knowledge in antiquity, what's certain is that Baalbek joins a long list of sites, proving humanity's deep, deliberate relationship with the stars. The Hidden Chambers Revelation. The AI's analysis of Baalbek reached a turning point when it processed ground-penetrating radar scans beneath the Temple of Jupiter platform. What it revealed were anomalies that did not resemble natural caves, but instead showed signs of deliberate geometry, lines, and shapes that hinted at man-made construction. These voids were located directly beneath the trilithon stones, raising extraordinary questions about their origin. Were the chambers built first, forming the foundation for the platform, or could they have been carved out later in a feat that defies our understanding of ancient engineering? Subterranean features at Baalbek are not entirely new. Archaeologists have long been aware of certain tunnels and passages beneath the site. Yet what the AI identified appears to be far larger, more intricate, and more deliberately planned than anything previously recorded. Theories abound as to their purpose. They may have been part of the building process itself, serving as staging areas for tools, machinery, or leverage systems needed to raise and position the colossal stones. Alternatively, their placement beneath the largest blocks might suggest they were intended as sacred spaces designed for ceremonies, initiations, or to symbolize a connection to the underworld. The possibility that these chambers remain sealed and untouched, since antiquity is what excites researchers most. If artifacts, inscriptions, or construction tools are preserved within them, they could completely reshape our knowledge of Baalbek's builders. Yet accessing them poses immense risks. The trilithon stones are load-bearing, and disturbing them could destabilize the entire platform. Some propose non-invasive methods like inserting fiber optic cameras or robotic probes through boreholes, but these require funding and delicate approvals. For now, the mystery of what lies beneath Baalbek remains sealed in stone, waiting for a safe way to uncover its secrets. The tool marks tell a different story. When artificial intelligence examined the microscopic tool marks on Baalbek's immense stones, it uncovered something that doesn't fit within the boundaries of conventional archaeology. Instead of the wear patterns expected from bronze or copper chisels, the stones revealed signs of a more complex process. The AI suggested that these were not the marks of simple hand tools, but rather evidence of advanced techniques that indicate experimentation with metallurgy, far beyond what we normally associate with the builders of antiquity. The analysis pointed to the possibility of composite tools, implements that may have combined softer metals with embedded, harder minerals or abrasives, allowing them to cut through stone more efficiently. Some of the evidence even hints at methods resembling thermal or chemical treatment of the rock, as if ancient craftsmen were testing multiple approaches to achieve cleaner, more precise results. The sophistication here suggests not trial and error, but deliberate design, the kind of thinking we see in modern industrial tools created for specialized tasks. Perhaps the most astonishing detail lies in marks that resemble ultrasonic cutting. While speculative, these fine vibration patterns echo the results of modern high-frequency cutting equipment. This raises the question, could ancient builders have somehow harnessed principles of sound and resonance in ways we are only rediscovering now? Even if the reality was less futuristic, the consistent and standardized nature of the tool marks points to training, organization, and a technical tradition, signs of a society with both knowledge and systems to preserve and transmit it across generations. What do you think? Were Baalbek's builders using lost knowledge or just incredible human skill with simple tools? Share your thoughts below. And if you enjoyed this dive into ancient mysteries, subscribe and ring the bell for more. History still has secrets waiting to be uncovered.